Hi and welcome Year 10 students to more IGCSE. We're looking today at exercise 2.10 from your textbook, which is on straight lines. There are a couple of concepts that we need to be aware of. Let's just refresh our memories of the y equals mx plus c function. This is a straight line function. And this here, the m, is equal to our gradient. So how steep the function is, and here the plus c is equal to our y-intercept. Okay, now a couple of things we can note. If we have it in this y equals mx plus c form, and if m is equal, then we are parallel. So for example, if we have an equation y equals 2x plus 3 parallel to y equals 2x minus 8. They will be parallel. That's one thing that we can tell from this. We can also tell, oh no, we've already talked about the intercept. So let's actually get straight into the exercise at this point, and we're going to do some writing down of gradient and y-intercept. So having a look at 1a, we've been given this equation here, y equals 3x plus 2. So this is the gradient, so I'm going to write m, or gradient, equals 3. Y-intercept equals 2. So that's pretty nice and easy, isn't it, really? Now, I won't do b, I'll do d. Here for d we have y is equal to 2/3 x minus 1. And we have a gradient, or m, is 2/3. And a y-intercept of minus 1. Sometimes we might get a negative, for instance this one here, if y is equal to 4 minus 5x. Now you've got to look very carefully. The m value is the one in front of the x, so it's minus 5 in this case, and the y-intercept is the 4. So don't get confused if they write things in a different order from what you're used to. So we say the gradient is equal to minus 5, and the y-intercept is equal to 4 equals 4. Now, in section 2, you'll notice that they've written things a little bit differently. So have a look at 2a, for instance. Here we have 2y is equal to 3x plus 4. Now you'll notice that in our original equation, all the way up here, you have y as the subject, but here we have 2y. So what we're going to have to do is first of all divide both sides by 2. So we get 3 over 2x plus 2. So I've divided each term by 2. And now I'm able to say m, or the gradient, is equal to 3 over 2. And the y-intercept is equal to 2. Now, just as a little bit of a sidetrack at this point in time, what does this 3 over 2 mean? Well, this is, whoops, let me just change pens at this point. This here is our, oh, I don't know what happened quite there. This is our y change, and this is our x change. So remember, gradient, we learnt this last year, is equal to the y change divided by the x change. So when you have a fraction, the numerator is your y change and the denominator is your x change. Okay, let's do a couple more for number 2. Let's go on to 2c. So for 2c, we've got 5y equals 2x minus 3. Now I want to get that y by itself, so I divide everything by 2, so I get 2/5 x minus 3/5. Now you can see that m, the gradient, is 2/5. and that the y-intercept in this case is equal to negative 3/5. That's where it crosses the y-axis. That's what a y-intercept is. Now they're not all going to be that easy. So for instance, you'll notice if we take a look at E, 2E, that the x's and the y, and I think there's a mistake in your textbook for this one. I think it should say 3y instead of 3x plus 2x equals 6. I think that's what it should be. That's what I'm going to take it to be anyway, otherwise it doesn't make any sense. Okay, so what we're going to do here is we're going to bring the x across to the other side, so subtract 2x from both sides. Why? Because I really want my formula to be in this setup here. I want it to be y equals something. So now I'm going to get y by itself by dividing both sides by 3 to give me negative 2/3 x plus 2. And so at this point I can say that m is equal to negative 2/3, and y-intercept is equal to 2. Now, you may need to do a bit of rearranging for some of these. I'll do maybe one more, just to give you an idea. So the next one, we've got 4x minus 2y is equal to 3. For this one, I want to get y's by themselves, so I'm actually going to move my 4x across by subtracting it. So I get this, negative 4x plus 3. Then I'm going to divide by 2, so I get negative y equals negative 2x plus 3 over 2. And then I'm going to times everything by negative 1 so that I've got y as my subject. So I get, whoops daisy, I get 2x minus 3 over 2. So just times everything by negative 1. And at this point you can see that my gradient, m, is equal to 2. And my y-intercept is equal to negative 3 over 2. Okay team, so that's how you cope with those. You may need to do some rearranging. Don't just be a Larry and not think and just automatically look at the number in front of the y. You have to get it into this y equals mx plus c form. Okay, so let's take a look further down. What have we got here? Okay, so in this this is question 3, and I've got to work out the gradients and the y-intercepts of each of the lines. So let's take a look at A. So with A, you've got a y-intercept of here is positive 3. And you can see that the gradient, every time I go across 1, I go up 1.5. Okay? Or another way of thinking about it, if you like, is every time I go across 2, I go up 3. 1, 2, 3. So let's try this out. Here's A. Y equals, now my y change, I've gone across 2, and I've gone up 3. So my y change is 3, and my x change is 2. So it's negative. It is positive 3 over 2x, or 1.5x, and plus my y-intercept, which is here, which is positive 3. So that's the first one. Let's take a look at B next. So B is going to be a negative one, isn't it? So B, we've got a plus 4 as our intercept, and look, we've gone down 1 after we've gone across 4. 1, 2, 3, 4. So we've gone down 1 and across 4. So down 1, the y change on top, the x change on the bottom, and there we go. Take a look at number C. C is a positive 1, isn't it? And it's got a negative 1 intercept, but the gradient is positive, isn't it? So every time we go across 2, we go up 1. So this is 1 over 2x. Finally, we're going to do D. Let's see where we get to with that. So for D, you can see D is also a negative gradient. it's going to be negative something. We know that it crosses at 5, so we've got a plus 5 as our y-intercept. And every time we go across 1, we go down. Ooh, it's very hard to see. So when you get a situation like this, you find out a place where it crosses in the corner, like in a vertex here. So then we can see, all right, I've gone across 1, 2, 3, and I've gone down 5. Okay, so negative 5/3. The y changes down 5 and then across 3. So that's a negative 5/3 x graph. Okay, so that's that lot. Now, for part 4, we've got to write down the equation of each of these lines. And so for A, we're going to say it's got a gradient of 0, which means it's a horizontal line, doesn't it? Okay, and it passes through 5, negative 2. So this is a y graph. Okay, y graphs are the horizontal ones. Y equals negative 2. Alright, B, got a gradient of 2 and it passes through the origin. So it's a y equals gradient 2x plus 0. It crosses at 0, 0. Or we can rewrite that as y equals 2x. Number C, we've got a gradient of 3. So it's y equals 3x graph. And it crosses through 0, minus 2. So 0, minus 2 is 0 is the x value and minus 2 is the y value. So it's a negative 2 intercept. Now the next one's, the next one's okay. It's E and F that we'll have to do a little bit more thinking for. So the next one, it's parallel to y equals 1/2 x. So we know that we've also got another y equals 1/2 x because parallel, it has the same m value. But this time, our y-intercept occurs when x is 0. So we have a y-intercept of plus 6. For E, you'll notice that this time we aren't given where it crosses the x-axis. So what we want to do with this one is a couple of things. We can rearrange it. So I'm going to say 4y equals negative 3x plus 12. And then I'm going to rearrange it to y equals negative 3/4 x plus 3. Now, if it's parallel to that, then therefore we know that we're dealing with a y equals negative 3/4 x graph, and we want to find the plus c value. Okay, now all we do at this point is we plug in these values here. So we put in a 5 for our y equals negative 3/4 times 2 plus c. And all we need to do then is pop this into our formula and find out what we get. So it should be 5 plus 3/4 times 2 would be c, and so c is 13/2. So for this one, I'm going to write y is equal to negative 3/4 x plus 13/2. Similar idea with this one for for F. First of all, I'm going to rearrange this formula that they've given me. It's 2y equals x plus 6. So y is equal to x/2 plus 3, or 1/2 x is another way of writing that. So therefore I know that my gradient in the parallel line will be 1/2 x as well, and then I've just got to find plus c. All I need to do is pop this information into my this data into my formula, and I will find out what c is. So negative, 1 is my y value. 1 equals 1/2 times negative 6 plus c. So we get c is equal to 4 in that case. So our equation will be 1/2 x plus 4. Alright, so the last little thing that I'll do with you is some questions from number 5. And we're just doing a little bit of sketching. Now sketching is exactly what you would imagine. A sketch, it's not a detailed diagram, okay? So we've got a sketch y equals x plus 4. So for this, here's my sketch. I know that it crosses at, not at negative 4, it crosses at positive 4. And if it's got a gradient of 1, it means every time you go across 1, you go up 1. That will mean that it crosses at -4. You can think about this very carefully. Every time I go across 1, I go up 1. Then if I go across +4 from here and then go up 4, I would get to there. That's how I got that so easily. The next one that I'll do is y equals 3x 3x minus 5. So for this one, we know that we're crossing here at -5, and we know that every time we go across 1, we go up 3. So it's a steeper graph. And if you want to find out where it crosses here, that's when y equals 0. So you can quickly rearrange this. So if y is 0, 0 equals 3x plus 5, minus 5. And you just rearrange this, so 5 is equal to 3x. So x is equal to 5/3. So it crosses the x-axis at 5/3. And that is all you need for that one. I will just do one more. And what I've chosen to do is h. You might want to try a few on your own. The reason I've chosen to do this is it requires a skill called 2-point plotting method. Okay. Now when you're sketching, you know that all the way along your y-axis, x is equal to 0, and all the way along your x-axis, y is equal to 0. So what we can do is we can say, alright, when x is 0, I get 5 times 0 minus 2y equals 10, therefore y equals -5. So we know that it crosses at -5. And then we can do the same with our x-axis. When we're on the x-axis, y equals 0. And so x in this case would be equal to 2. So I've got something there, we join her up, and that's our quick sketch. Okay, so that's all you're expected to do for this exercise. Hope that's been helpful, and we'll continue talking about line equations and figuring out the lines passing through some points tomorrow. Alright team, God bless, see you later.